Okay, so we're going to start a new unit, and it's the exponent of functions unit. All right, so I'd like you to do the try this, so put me a pause and then come back and check your answers. Okay, so let's take a look at the first one. It says x to the fifth times x to the third. So that is x to the eighth. X to the fifth divided by x to the third is x to the second. X to the fifth raised to the third power is x to the 15th. Xy to the third power is x to the third, y to the third. X divided by y to the third power is x to the third divided by y to the third. Okay, so let's write down our rules. So we have the rule for multiplying the same base. So when I multiply the same base, right, when I say base, I'm talking about the x's here, right, x and x. So it's x to the a times x to the b. When you multiply same bases, you add the exponent. So it's x to the raised to the a plus b power. When you divide the same bases, x to the a divided by x to the b is x to the a minus b power. When you have a power to a power, so an exponent raised to another exponent. So that's x to the a times b power. So x to the ab. So using this same rule here, down here, when I have x to the b times c raised to the a power, that's x to the ab, y to the ac power. X divided by y raised to the a power is x to the a divided by y to the a. A negative exponent, move everything up a little bit. A negative exponent. When you have a negative exponent, to make the exponent positive, it goes into the denominator. So it'd be x to the a power. And vice versa. If you have 1 over x to the negative a, you can make the a positive by putting it into the numerator. So basically, you can move things from numerator and denominator just by changing the sign of the exponent. So we have x over y raised to the negative a power. That's x to the negative a, y to the negative a, and to make them positive, you flip it. So it's y to the a over x to the a power. All right, so take a look at the example below. It says use the properties of exponents to determine which functions, I should say functions, are the same. So I have here f of x is equal to 4 raised to the x minus 3 power. So since I have x minus 3 up here, that's really 4 raised to the x plus negative 3, which is actually 4 to the x times 4 to the negative 3 power. Because when I have the same base, I add the exponents and I would get 4 to the x minus 3 power. Okay, so this one here, this would be 4 to the x minus, another way to write 64 would be 4 to the third power. So that's actually 4 to the x minus 4 to the third. These though, however, are not the same because this is multiply and this is subtract. All right, and the last one, 1 over 64. So I can rewrite 1 over 64 as 64 raised to the negative 1 power because the exponent for 64 is negative 1. Or you could think of it like this. This is 1 over 4. 64 is actually 4 to the third power. So now I can move this to the numerator by changing the sign of the exponent. So it's actually 4 to the negative 3 power times 4 to the x power, which these here are the same. So f of x and h of x are the same. Okay, so flip it over and let's talk about graphing. So make sure you have your graphing calculator in front of you. If you don't, please go get it. Okay, so an exponential function. So I have f of x is equal to a to the x power. So that's an exponential function where a, your base, has to be greater than 0. And a cannot be equal to 1. The reason why it can't be equal to 1 is because then I just get 1 across the board, which is linear. And your x is going to be all real numbers. All right, so I have here, let's graph f of x is equal 2 to the x power. So I'm going to make a table of values, so you can plug it into your calculator to get your table. So I have x and y. So I'm going to use -3, -2, -1, 0, 1, 2, 3. All right, so plug in your calculator, and when x is -3, I get 1/8. When x is -2, I get 1/4. When x is -1, I get 1/2. When x is 0, I get 1. 1 is 2, 2 is 4, and 3 is 8. So let's graph it. Okay, so it gets really small over here, and it goes up like that. Okay, so this is f of x is equal 2 to the x power. Okay, so then what do we know? We know the domain. Remember, the domain are your x values, right? Left and right. So that's from -infinity to infinity. We have our range. My range is, well, it's not hitting the x-axis, so let's actually write that down. The x-axis is an asymptote. So your asymptote is y is equal to 0. So my range is from 0 to positive infinity. One thing you need to know is that all exponentials go through the point 0, 1. So all exponential functions pass through 0, 1. It won't go through 0, 1 when you have a transformation. Okay, so let's take a look at number 2. Okay, so I have f of x is equal 2 to the negative x power. So this is actually f of x is equal to 1 over 2 to the x power. So let's make a table of values. So I'm going to use -3, -2, -1, 0, 1, 2, 3. Plug it in your calculator. We get 8, 4, 2, 1, 1/2, 1/4, and 1/8. Okay, so let's plot the points. Okay, so it looks like this. All right, so this is f of x is equal to 2 to the negative x power. Okay, so now going back to my function, my exponential function, remember my exponential function looked like this? This is f of x is equal to the x power. So notice that when I start with this function here, and I then have this function, it's actually a reflection over the y-axis. So f of x, which is equal to the x, that's my original, and now I have f of x is equal to the negative x power. And I said it's a reflection over the y-axis. And remember, what's the rule for reflection over the y-axis? The x value changes to negative. And notice that my x value here is its opposite. All right, so what's the domain? Domain is the same thing, so it's from -infinity to infinity. The range is from 0 to infinity. And my asymptote, same thing, is y is equal to 0, which is the x-axis. Okay, so why don't you flip it over and we'll try the next one. Okay, so I have f of x equals -2 to the x power. So let's make a table of values. Plug it in your calculator. We're going to go from -3 to 3. Okay, so look in your y table of values. Your y values are -1/8, -1/4, -1/2, -1, -2, -4, and -8. Okay, so let's plot the points. Okay, so this is f of x is equal to -2 to the x power. Okay, so now let's just put our f of x equals 2 to the x, what I started off with before, which looked like this. All right, so that was f of x is equal to the x power. Okay, so I have here, I started off with f of x is equal to the x power, right? And then I have f of x is equal to -2 to the x power. And notice that it is a reflection over the line y equals over the x-axis here. So remember the rule for a reflection over the x-axis. xy becomes x negative y, and that makes sense because look where my negative is. My negative is on the bottom with my base, right? So what else do we know is that my domain is same thing, -infinity to infinity. My range now is from -infinity to 0. And I have an asymptote, which is the same thing as before. Y is equal to 0, which is the x-axis. All right, so we got one more to do. Okay, so that is f of x equals -2 to the -x power. Okay, so let's make a table of values. -3, -2, -1, 0, 1, 2, 3. Okay, plug it in your calculator. You get -8. -4, -2, -1, -1/2, -1/4, -1/8. Okay, so let's plot the points. So I have -3, -8. Okay, so that is f of x is equal to -2 to the -x power. Okay, so remember my original function, my parent function. It was this here. Okay, so that's f of x is equal to 2 to the x. All right, so let's look at that. F of x is equal to the x. And now I have f of x is equal to -2 to the -x. So my y and x are different, so are opposite. So that's, hopefully you remember, is a reflection through the origin, which is the same thing as a rotation of 180 degrees, which means xy becomes -x, -y. Okay, so what is the domain? The domain, same thing, -infinity to infinity. My range is from -infinity to 0. And I have an asymptote, and that's the same thing. Y is equal to 0. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.